This is the 7.1 to 7.3 study guide for Tuesday's test. Please remember that you're using this as a tool. Do not copy all of the answers. All right, the first problem is a complex fraction. When you're doing a complex fraction, you need to make the numerator a single fraction, the denominator a single fraction, and then multiply by the reciprocal of the denominator. So the numerator and denominator are already single fractions. So I'm just going to go ahead and multiply by the reciprocal of the denominator. So I have x plus 7 over 3 all over x minus 7 over x. Very important to put parentheses around your expressions so you don't get confused later when you need to distribute. So I am multiplying by the reciprocal of the denominator. Remember, your reciprocal means that you flip over the fraction. This and this are going to cancel, and this are going to cancel. And then you're just left with x plus 7 over 3 times x over x minus 7. Oops, I forgot the x. There you go. Okay, nothing cross cancels in this situation, so you're just going to say x times x plus 7 over 3 times x minus 7. And that is your answer. Okay, now factoring using right way, wrong way. Remember, your first step is you're going to multiply your first and last term together. So your first and last term would give you 90. Factors of 90 are 1 and 90, 2 and 45, 3 and 30, and remember I'm looking for factors that will give me 21. 5 and 18, and 6 and 15. At that point, 6 and 15 can give me 21, so I'm going to use those. So you're going to build your houses. So you have 10x here and 10x here. There should be a plus here, guys. Sorry about that. So then you have plus, plus. Larger number always goes first, 15 and 6. And then divide out of each house what they have in common. The first house has a 5 in common. So 10x divided by 5 is 2x. 15 divided by 5 is 3, so it's 2x plus 3. 10x divided by 2 is 5x. 6 divided by 2 is 3. So you are fully factored right here. And of course, you can distribute to check your answer. Okay. If you have the square root of 196 over 289, I'm going to break up my square root and make it the square root of 196 divided by the square root of 289. The square root of 196 is 14, and the square root of 289 is 17. If you didn't know that, you do know that the square root of 144 is 12, so 144 is pretty close to 169, so you should know that it's somewhere around 12. Negative square root of 36, the square root of 36 is 6, and then we're just going to put our negative out in front of it. Square root of 64, x to the 14th. I'm going to take the square root of 64 times the square root of x to the 14th. Okay? Square root of 64 we know is 8. We also know that there's an index here of 2. If we take our index back and make it our denominator, 14 divided by 2 is 7, so it's just 8x to the 7th. Square root of negative 576, if you have an even index, which in this case we do, it's 2. then you cannot have a negative under the radical. So this is not a real number, which is different from no solution, guys. Don't write no solution, because that's not true. There is a solution, it's just an imaginary number. Okay, cube root of negative 729. It's okay to have a negative under the radical if your index is odd. So basically you're asking yourself, what times itself gives you negative 729? And that is negative 9. If you wanted, you could make a factor tree, and that would also get you there. Here we have the cube root of 343, x to the 6th. So we're going to take the cube root of 343 times the cube root of x to the 6th. Now, hopefully by now you know that the cube root of 343 is 7. And we're going to take our index back here and make it our denominator. And we know that 6 over 3 is 2. So it's 7x squared. Here we have the cube root of 1 over 27. So again, I'm going to use the quotient rule to break it up as the cube root of 1 over the cube root of 27. The cube root of 1 is 1, and the cube root of 27 is 3. So your answer is just 1/3. Okay, here we have negative cube root of negative 64x to the 18th y to the 36. I'm going to leave my negative out front, and then I've got the cube root of negative 64 times the cube root of x to the 18th times the cube root of y to the 36th. So cube root of, keep your negative out front, cube root of negative 64 is negative 4. Cube root of x to the 18th, you're going to bring your index back, make it your denominator, and that's going to leave you x to the 6th, because 18 divided by 3 is 6. And then we've got the cube root of y to the 36th. Again, I'm going to bring my index back, and then I'm going to say 36 divided by 3 is 12. So I have y to the 12th. And we know a negative is actually a positive. So my answer is going to be 4, x to the 6th, y to the 12th. Okay, the 6th root of x to the 42nd. I'm going to take my index back and put it as my denominator. We know that 42 divided by 6 is 7. So my answer is just x to the 7th. Here we have the 4th root of 81 times the 4th root of x to the 8th times the 4th root of y to the 16th. The 4th root of 81 is 3. The 4th root of x to the 8th, take your index back, make it your denominator. 8 divided by 4 is 2, so it's x squared. Take your index back to your denominator. 16 divided by 4 is 4, so it's y to the 4th. So your final answer is 3x squared y to the 4th. Fourth root of 16x to the 4th over the 4th root of y to the 8th. Okay? Now, the 4th root of 16 times the 4th root of x to the 4th over the 4th root of y to the 8th. The 4th root of 16, we know, is 2. The 4th root of x to the 4th, remember, the 4th root and the 4th cancel each other out, just leaving you x. And then here we're going to take our index back to our denominator. 8 divided by 4 is 2, so it's just over y squared. Okay, when you are multiplying like bases, you add the exponents. So we have x to the 5/8 times x to the 3/8. Oh, I wrote that backwards, but it doesn't matter. equals x to the 5/8 plus 3/8. When you are adding fractions, you need a common denominator. I already have that. So I just add my numerators. So it becomes x to the 8/8 because 5 plus 3 gives me 8. And then we just keep our common denominator. And 8/8 is just 1. So it's x to the first power, but we don't write to the first power. Okay, when you're dividing like bases, you subtract the exponents. So I'm going to say y to the 3/4 minus 1/4. They already have a common denominator, so all we're going to do is subtract our numerators. So it's going to become y, 3 minus 1 is 2, and you keep your common denominator. 2/4 is the same as 1/2, so your answer is y to the 1/2. And if they asked you to write that in radical form, you would just take your denominator and make it your index, so it would be the square root of y. And that's if they wanted it in radical form. Okay, when you're taking a power to another power, so we've got b to the 7th to the 2/7 power, we're going to multiply our exponents. So it's b to the 7th times 2/7. Go ahead and put your 7/1. And remember, when you're multiplying fractions, you just multiply straight across. So this becomes 14/7, which we know is just 2. So it becomes b squared. Okay, the first thing you need to do on this problem is give your cube to both the -4 and the x to the 4/3 because of the parentheses. So it's -4 cubed times x to the 4/3 cubed all over x to the -2/3. -4/3 is -64. And if you take a power to a power, which is 4/3 to the 3rd power, you multiply the exponents. So it's x to the 4/3 times 3, and we'll say times 3/1. I'm sorry, not 3. All over x to the -2/3. Now, because you have a negative exponent, remember the saying, negative exponent in the numerator, drop it like it's hot. Negative exponent in the denominator, raise it to the top. So we're going to take this and we're going to raise it to the top. Okay? So I'm going to have -64 x. When I multiply my numerators, I get 4 times 3 is 12. Over 3 times 1 is 3. And then remember, I'm going to bring this to the numerator because of the negative exponent. So it's going to be times x to the 2/3. And when you bring it to the numerator, you drop the negative. Okay, so now I have like bases, and so I need to add my exponents. So I have -64 times x to the 12/3 plus 2/3, which is going to give you -64x to the 14/3, because we have a common denominator of 3. So you're going to say 12 plus 2 is 14, and that can't be reduced any, so we just leave it like that. Okay, here we're going to go ahead and take our index and make it our denominator. So we're going to get x minus 5 to the 2/4 power. However, we don't leave 2/4, so it would be x minus 5 to the 1/2 power. And we could either leave it like that, or if they asked for it in radical notation, we would take our denominator and make it our index. So it would be the square root of x minus 5 if they asked for it in radical form. Okay, here we have the 35th root of y to the 21st times the 35th root of z to the 30th. So we're just going to take our indexes back, and this becomes y to the 21 over 35, and this becomes z to the 30 over 35. And hopefully you can see right away that both of those can be reduced. The y exponent can be reduced by by 7, leaving me 3 over 5. And the z exponent can be reduced by 5, leaving me 6 over 7. So you can either leave your answer like that, or if they're asking for it in radical form, you would take your denominator and make it your index, denominator and make it your index, and it would be the 5th root of y to the 3rd times the 7th root of z to the 6th. And that's if they wanted it in radical form. Okay, because both of these are the same index, I can multiply them together. But before I do that, I want to go ahead and simplify this sum, because if I multiply 64 times 125, I'm going to get 8,000, and that's an awfully big number. So I'm going to go ahead and simplify first. The cube root of 64 is 8. And the cube root of m cubed is just m, times the cube root of 125 is 5, and the cube root of m cubed is just m. So 8m times 5m is 40m squared, and that is your answer. Okay, here we have the 4th root of 2x cubed times the 4th root of 343. Neither of these can be simplified any further, because if we take 343, that's 7 times 49, and 49 is 7 times 7. In order to be able to pull a number out front, we need 4 of them, and I only have 3 7s. So I know they're both in their simplest form. So all I can do is, because they have the same index, I can multiply them together. So I have 2 times 343, and then x cubed. So then that's going to be the 4th root of 686 x cubed. And unfortunately, that's really all I can do with that one. Okay, here we have the square root of 32 over the square root of 49. It's a lot easier to break it up like that. Now, the square root of 32 can be simplified. It's 16 times 2, and then 4 times 4, and then 2 times 2, and 2 times 2. Okay, so in order to pull a number out front, I need 2 of them. So I have 1, 2, that's 1 I can pull out front. 1, 2, that's 2 I can pull out front. And then I have 1 left over. So that's going to become 4 square roots of 2. And the square root of 49 is 7. So it's 4 square roots of 2 over 7. Okay, same thing here. I can go the square root of 48 x squared over the square root of 25. Now, the square root of 48 is not a perfect square, so let's see if I can break that down at all. 48 is 24 times 2. 24 is 6 times 4. 6 is 3 times 2. And 4 is 2 times 2. Okay, so in order to pull a number out front, I need 2 of them. So I have 1, 2. That's 1 I can pull out front. 1, 2. That's 2 I can pull out front. And I'm going to leave the 3 inside. So if I pull 2 2's outside, that's 4. And then I've got the square root of 3 inside. And then the square root of x squared, we know, is just x. So that's also going to go on the outside. And we know the square root of 25 is just 5. So my answer is 4x square root of 3 over 5. Okay. Now, this is a little bit different. Before, we were going from one root and we were breaking it up into a root in the numerator, root in the denominator. Now we have a root in the numerator, root in the denominator, so my first guess for what I should do is put it all under one root. Now by doing this, we can say 140 divided by 5, which is 28. And we end up with the square root of 28. And then we can see if we can simplify the square root of 28. 28 is 14 times 2. 14 is 7 times 2. In order to bring a number out front, you have to see what the index is. Here my index is 2. So I'm going to say I can bring a 2 out front, and I have to leave a 7 inside. So my answer is 2 square roots of 7. Okay, square root of 32 over the square root of 1600. So let's see if we can simplify them both. What times what gives me 32? Excuse me. 8 times 4. 8 is 4 times 2. And then 4 is 2 times 2. And then this 4 also is 2 times 2. So in order to pull one out front, remember we have a 2 there, so in order to pull one out front, I need to repeat twice. So 1, 2, that's 1, 2 I can pull out front. 1, 2, that's 2 2s I can bring out front. And I'm going to leave a 2 inside. So if I'm taking 2 2s out front, that's 4. And then I leave a 2 under the square root. So that's going to be my new numerator. So this is going to be 4 square root of 2. And then 1600 can be broken down to 40 times 40. Now you can go further, or you can realize that you only need something to repeat twice in order to pull it out front. So the square root of 1600 is just 40. So that means I have 4 square roots of 2 over 40. Now, anything that's outside the radical can be reduced. So we're going to reduce this 4 over 40 to 1 over 10. And then our answer is going to be the square root of 2 over 10. Okay, let's try this again. The square root of 98 is not 9 times 8, because 9 times 8 is 72. So what times what gives me 98? Let's go with 7 and 14. Those actually multiplied together to be 98. 7 can't be broken down anymore, but 14 can be broken down to 7 and 2. And remember, if my index is 2, that's how many times a number has to repeat in order to bring it out front. So that is 7 out front. And then the square root of 2 is what, or 2 is what's left under the square root. So your answer is 7 square roots of 2. Square root of 33. We can break that down to 3 and 11. Neither one of these can go any further, so you know the square root of 33 is as simple as it can get. Fifth root of 96. What times what gives me 96? I'm going to go with 24 and 4. We know 4 breaks down to 2 and 2. 24 breaks down to 6 and 4. 6 is 3 times 2. And 4 is 2 times 2. Remember to cross them out as you go. That way you don't get confused with what's left. In this case, I'm going to need 5, a number to repeat 5 times before I can bring it out front. So I've got 1, 2, 3, 4, 5, which means I can bring a 2 out front. And then I'm going to leave a 3 behind. And remember, you started with a 5th root, so you will end with a 5th root. Don't forget about your 5th root. So it's 2 times the 5th root of 3. Here we have the square root of 54 times the square root of x squared times the square root of y. 54 can be broken down to 27 and 2. 27 can be broken down into 3 and 9. And 9 can be broken down to 3 and 3. In order to bring something out front, in this case, you're going to need 2 of them because your index is 2. So 1, 2, I can bring a 3 out front. and then I've got a 3 left behind in the radical, and a 2 left behind in the radical. So we're going to multiply those together to get 6. Times, remember, your square root and your square cancel each other out, leaving you the absolute value of x, which is just x. And in this case, I'm just going to go ahead and leave the absolute value, the square root of y behind. So we're going to multiply together what's outside of our radical, which would give us 3x. And then because both of our indexes here are 2, we can multiply what's underneath the radical, leaving us 6y. So our answer is 3x times radical 6y. Okay, here I'm going to take the square root of 50 times the square root of x squared. 50 is 25 and 2, and 25 is 5 and 5. Because my index is 2, I need a number to repeat twice before I can bring it out front. 5 repeats twice, leaving me with a 2 under my radical. And then here, remember, your square root and your square cancel, leaving you the absolute value of x, which is just x. So I'm going to multiply what's outside of my radical together, which is just 5x, times the square root of 2. In this case, we have a radical in the numerator, radical in the denominator with the same index, so we could write it all under one radical. But I don't think that's going to help us in this situation. In this situation, we have the square root of x to the 9th. So remember, this is a 2 here. And the square root of 36. So I'm going to take this 2, and I'm going to bring it back here and make it my denominator. And I'm going to ask myself, how many times does 2 go into 9? So I have 9 divided by 2. How many times does 2 go into 9? It goes into 9 4 times. So that means I can bring 4 x's out front. Now 2 times 4 is 8. So how many x's do I have left over? I started with 9. I used 8 of them. So I have 1 left over, and that's what's going to stay inside my radical. And we know that the square root of 36 is just 6. So your answer is x to the 4th times the square root of x over 6. Now, if you have a real difficult time with this concept, you can always say 1, 2, 3, 4, 5, 6, 7, 8, 9. That's my x to the 9th. Now, how many do I need to repeat in order to bring it out front? 2. So you can say 1, 2, that's 1 out front. 1, 2, that's 2 out front. 1, 2, that's 3 out front. 1, 2, that's 4 out front. And then you're just left with 1 inside. So you'll get the answer either way, whether you used this method or this method. Okay, here you have the square root of 189, x to the 5th, y to the 6th, and then square root of 3y to the 4th. So because they have the same index, I'm going to go ahead and write them all under one radical. So it's going to become the square root of 189 x to the 5th, y to the 6th, all over 3y to the 4th. And I'm going to reduce anything I can. Okay, y to the 4th is going to reduce my y to the 6th to y squared. 189 divided by 3 is 63. So I can reduce this to 63. So then I have the square root of 63 x to the 5th y squared. And then let's simplify that. So I'm going to have the square root of 63 times the square root of x to the 5th times the square root of y squared. Okay, so let's break up the 63. 63 is 7 times 9, and 9 is 3 times 3. In order to pull a number out front, I'm going to need 2 of them because my index is 2. So I have 1, 2, that's going to bring a 3 out front, and I'm left with a 7 behind inside my radical. Here, I have my index of 2, which I'm going to bring around back, and that gives me 5 over 2. How many times does 2 go into 5? It goes into 5 2 times. So that means I can bring 2 x's out front, So 2 times 2 is 4, and how many do I have left over? If I used 4 of the 5, I have 1 left over. And remember, you can always write out your 5 x's, which would be x times x times x times x times x times x. And then I need 2 in order to bring 1 out front. So that's 1, 2, bring 1 out front. 1, 2, bring 2 out front, and leave 1 inside. You'll get the same thing here either way. Okay, and then I'm also going to do, we know that a square root and a square cancel each other out, leaving you the absolute value of y, which is just y. So now let's clean this up a little bit. I'm going to multiply whatever I have outside the radicals together. So that's going to give me 3x squared y. And then because both of my radicals have the same index, I can multiply whatever's underneath the radical together, which would be 7 times x, which would be 7x. So your answer is 3x squared y times the square root of 7x. And that's it. That's the whole study guide. You guys have a good night, and I will see you tomorrow.